So let's give this one a try. I tried it a couple weeks ago and it failed, maybe last week, but I think it's much better now. I had to update a lot to get to Windows 11. So turn off the firewall, run Vuln server, which we've already got, and I'm going to run it in Immunity. And we're going to target EIP. So let me start by setting up my, I'll need a Linux attacker, actually, so I shouldn't have turned this off. I'll run a Linux machine here, and it's going to run on ARM, which is fine, because all I'm going to be running is Python and Metasploit on here. Okay, good. So it's Debian and Debian and IPA. All right, so the Linux machine is 192.168.111.152. Uh, 121, 152. Okay, good. All right. Okay, and I'll, all right, and this will do, any machine will do. This is ED309. All right, oops, all right, good enough. Now, all right, so I want to make, this is going to test to see if I have you're going to make non-repeating characters. So nano test NR, put in that. All right. So this is just going to make, I have 10 letters and another 10 letters. I'm just going to add them here. All right. So let me go back here and see, let's get rid of this stuff that's in my way. All right. I think we have to do a little fuzzing first. Okay, what we're going to do here, all right. We're going to test, we're going to send 3,000 characters here. Attack, we're just going to print it on the screen. Okay, this is going to make padding, prefix plus test, I understand. Okay, I believe from before, what we've done before, that 3,000 characters is enough to make the crash that's interesting. And so what we're going to do is make a pattern of 3,000 characters that doesn't repeat. That's the idea. And so you'll see this kind of thing. That's a form of attack string. Let me just run that. And I've got to get rid of these things that don't matter that keep coming up. All right. So let's run that. Python 3 tester. All right. So this creates a string of 3,000 characters, a lot of A's, then a non-repeating section in the middle, and then a lot of F's. And I know from previous tests that somewhere in here is where the extended instruction pointer is going to be. And the reason I'm doing this is because it depends on your version of Windows. It's 4 bytes different between Windows 10 and Windows 11, and I think it was something different on server. So you have to find out where the EIP is. So you got this thing, now we're going to send that to the server. So this is going to be find EIP. So I go here, put in that code, and now I have to fix that address to be the address of my Windows machine, which is going to be 172.18.24.49. All right, so now it's going to send 1,900 A's, then that non-repeating stuff, which is AA, AB, AC, and so on, then enough F's to add to a total of 3,000, and send it to the server. That's all it's going to do, and it's going to start with a trun space period, which is what gives you, this is the same buffer overflow we exploited last week, or week before. That simple buffer overflow, if you send 3,000, some of those characters ended up in the executable in the EIP. So if I run this one, EIP, okay, now I got to make sure the server is running in Immunity. So let me get to my Windows server. Okay, and let's get unnecessary stuff away. Okay, let's run Immunity and run vuln server and start it. So now it's running and listening. So now if I send this stuff, it should crash here. And see, it did crash. Access violation when executing 65, 66, 64, 66. So there's a couple of printable ASCII characters. That's what I wanted. So those are lowercase ASCII characters. Uppercase start with 40 and lowercase start with 60 for the first 16 characters. So those are 4 characters. So it was, and I think it's probably going to be what I saw here. Yep, 65, 66, 64, 66. So that's FDFE. FDFE, reading it backwards. So that is here, FDFE. So I can figure out where that is. And so that's 1900 A characters, then the one starting with A, B, C, D, E, those are 20 characters each, and then 6 before that. So it's a total of 2006 characters before the EIP.
But we knew this ahead of time.
Well, I knew the region. Yeah, I'd already done it on Windows 11, so I get the same answer. But yeah, rather than having to make thousands of non-repeating characters, I narrowed it down to a region of 100 repeating characters. I knew that, yeah. And so now I can hit EIP with that. So the only thing I have to change is this stuff. I don't like having to retype in the address, so I'm going to copy, find to hit EIP, and then a nano hit IP. And then the part I'm going to change is only that part there. So I can get rid of this stuff. There. That should, oh, and I have the padding. All right, then I can get rid of all that. There. So all I've done is put 2006 A's and then B, C, D, E, and then let the rest be padding. So I'm going to see if I can hit the instruction pointer with that. So let me restart my target here with debug, restart, yes, and then it's loaded and I have to hit run to run it. So now it's listening. Now I run, hit EIP, and now it quits when executing 42, 43, 44, 45. That's B, C, D, E. So now I know I can hit the EIP precisely. So now, I've done that. Now I'm going to test code execution on the stack with test NX. So this is the only part that has to change for that. So I copy, hit to test NX, because I don't know if I'm going to be able to execute code on the stack. Whoops. Okay, so put in that part differently and get rid of the old stuff. There, so now I'm going to have 2006 and I'm going to get this value. So let me get rid of this. I think I need to move back here. Oh, from the previous project, we've done this before. We used Mona, and we found that this address, 6250 11AF, will execute jump ESP. So it will jump to the stack. Now, if you take the previous break, let's examine that previous break, collapse again, get this one running, and let's send the hit EIP again. Oh, wait, what is this garbage? What was that? Don't know how to continue. Oh, okay. Oh, good. I didn't restart it. It's still where it crashed. So now we can look at ESP. See, look at right here. You see FFFF? If we look at the EIP and dump it in the dump here, you'll see there's FF. And if you scroll up, see, there it is. So the stack pointer, I put in the A's, here's the BCDE, and the stack pointer is pointing right there. So I can put the code to execute right there and execute it. And it won't matter that I have address space layout randomization running. It'll find it. So now I know where to put the code. So here, this should jump to that location. So now, instead of just putting in the F's, I'm going to put in NOP-SLED and break, and then padding. So NOP-SLED will be 1690s, and the break will be a CC, right after the EIP. And for the EIP, I put in that address, 6250 11AF, which is a jump ESP. So if I can execute code I've injected, it will slide down the NOP sled and hit the brake. That's the idea. So let me restart it here with debug restart.
You're saying the knob pads will slide, will move.
NOP will do nothing and move to the next instruction.
Right.
So it'll go NOP, 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 and then hit the brake, and the brake will come back to the debugger. Yeah. So I'll be able to tell if it worked. If the stack is not executable, it will refuse to execute the NOPs. Now, why is this not running? It says it is running. All right, good. All right. So now, so this is what I want, and that should be cat test NX. So there it is. That defines the pointer to jump ESP, and here's the NOP sled, and there's the brake. And that's what I put right here after EIP. So if I do Python 3 on this thing, which is test NX, okay, connection refused. Well, that's rude. Maybe my thing is not listening. It says it's running. Let me try debug restart. Seems like I had some unable to terminate process. Something bad has happened. Okay, I'm going to close this. Okay, yeah, something crashed on me. All right, and Windows Update is doing God knows what to us. All right, let's see if I can get this. Okay, there it is starting again. View, CPU. Okay, we're finally back to the regular view. Now run vuln server. I didn't see any, there we are. Now I didn't see this code before. Something was wrong. When we start it again, this is better. And let's see if I can get rid of this garbage. Now it's running. All right, let's try that again. There we go. All right, and now it hit the int3 command. And this stupid Windows 11 keeps popping advertisements on the screen. But anyway, and you can, if you roll back up here, you can see it slid down the NOP sled. Here's the 625011AF. Here's the A's. Here's what I've injected. A lot of A's. Then this address, which meant to jump ESP and came back, and then NOP, 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 until it gets down to the brake. So now I know I can find the code despite address space layout randomization, and I can execute code on the stack, which is pretty nice, which means this program is compiled not to support NX. Remember, we did before that test to see what security measures are in there, and this code was compiled with an old version of Visual Studio that didn't implement NX. So that's pretty nice. At least that's my understanding. So now I know I can execute code on the stack. So I'm in business. So now I'm going to turn on data execution prevention, which apparently is turned off on this machine. So let me go to System Settings and turn it on to prevent that, because this shouldn't be allowed, and indeed modern versions of Windows typically don't allow it. So let's search for System Settings and Advanced System Settings. And then here you can do Performance Settings, and here's data. Right now, DEP is turned on only for essential Windows programs, but you can turn on DEP for all programs. This is the more secure setting. Client-side versions of Windows like Windows 10 and Windows 11 are typically set up this way. They're less secure, but they can run old programs because home users probably do want to run old games and stuff. Servers are usually set up this way, saying you really shouldn't be running old junk on your server.
Okay, yeah, because the gamut of software that you are expecting is more.
Yeah, also they're much pickier about drivers. They won't run old hardware either. Servers are pickier, client sides are much more tolerant of old stuff.
Is this the panel that, regardless of which options is clicked, is this the panel from which that message you're running something downloaded from the web may be insecure?
No, that's completely different. That came later, yeah. This came out with Windows Vista. So after you do that, you have to restart the machine to make it take effect. So I'm going to restart this server, and that will lose the RDP connection, of course.
So so then I don't understand the prevention. This
Yeah.
is preventing for running.
Yeah, this implements the NX feature, which can mark regions of memory non-executable. And this implements that defense I mentioned, is to be write or execute. So now the stack that I can write to will not be executable. This is a desirable defense, I say.
That stack means that part of the stack, a specific part.
Well, it only applies to a whole segment of memory. So it's the all or nothing. So it's the whole stack or none.
I get it.
But all right, so let's go back to here. Here. All right, and hopefully the number didn't change. It didn't. Good, that's nice. Okay. All right, so now I can get back into my Windows machine and make it smaller and fit to window. All right, so here's my Windows machine again. So now it's running Windows 11 again, but it should have non-executable memory. So the same attack should no longer work. So if I go here, File, Phone Server, and run it, and I send it the same attack we just used, now it has an access violation when executing this command. And that command is a NOP. So what happens is, I was able to do this redirection, 6250-11AF. It then went to jump ESP and came here, but it will not execute this NOP because the whole stack is non-executable. So this is the defense that we're planning to overcome this time. So now we made an operating system that won't let us do that kind of buffer overflow anymore. All right, so it fails. So now we need to use ROP, return-oriented programming. This is the solution. Now notice what happened here. We got away with something. We were able to do this, 6250-11AF, and control execution. We can put addresses on the stack, and they will be used. We just can't put commands on the stack, because the addresses are not executable. You read them and use. So all we have to do is find addresses that will build the exploit we want. So if you write your exploit in assembly code and you find one or two statements and you find them somewhere, those two statements and then return, and the next two statements and then return, and just build it like you would build a ransom note by cutting words out of the newspaper, you could actually build an attack out of fragments of code you find. So all you do is put addresses here, and that adds up to an attack. It's tedious and difficult, but there is software that will do it for you, and that's Mona. Mona will build a ROP chain, the same tool we used before. It will build a ROP chain for you. So I can start it here and let it run, and it will take a while. I think it'll take about 2 minutes to dig through. It's going to run through all the DILs and find chains of useful gadgets. Now it turns out, in order to make it simpler, you don't build a Metasploit shell. You just build a gadget that will turn off NX. Like I said, this is how you defeat it. You build a gadget that will turn it off. And here's what it does. It finds pop EAX return, then it finds pointer to virtual allocation. It finds a way to allocate some memory that is going to be executable. So it's using using a couple of Windows API calls that affect the permissions of memory. That's what it's doing.
So basically, you're trying to put on the stack the command for shutting down the NX.
Yes, exactly. Without having any executable things, just addresses. So I'm just taking pieces of code that's already there and building enough assembly code to turn off this defense, which, as you can see, takes about 20 commands, about 20 addresses.
Yeah, that's versatile. I mean, this is something.
And it has to hunt through a lot of stuff. It used to take hours, and this one only takes about 2 minutes to find it. So eventually I will find, right, I just copied the clipboard for this one, and I will find register setup for Virtual Protect. So we'll get here. Let me see, it's going, yes, and this stupid advertising all over the screen because it's Windows 11. It says searching in the bottom left. So it's still running. It'll take a couple of minutes. So I'm going to find the code here. Here's the ROP chain. It's just a series of addresses. And then comments tell you what they are. And you see that many addresses will add up to turning off this defense.
It doesn't matter. They're not even adjacent to each other.
Oh, no, they don't have to be. Each one of them has to be just right near the end of a routine. And by the way, the defense against this is in modern versions of Windows, you can turn on a defense that will only let you enter library code at the expected address. Right. You can't jump in near the end, which is a pretty obvious defense. But that came later. And you only have it, I think you can, it's on the server versions of Windows now. So this attack won't work on server versions anymore. And I think you can turn it on in client versions. You can download a special thing from Microsoft to make your client as secure as the server. And then I think that would stop this. But it still works on Windows 11, which is pretty nice. So I think it's done. If it's done, I should be able to see the answers in the log window. Yep, ROP generator finished. So the simplest thing to do is copy to clipboard, whole table, and then paste it into Notepad so we can wander through it and use it. And I don't care about that. I'm in a new Notepad window. Oh, Control N. All right. My attempt to use Notepad has failed. Let me try again. Notepad. They've added tabs to Notepad, and I don't know how to use them. All right, there. Now Control V. There we are. So now I've got this stuff, and Java is kind of, yeah, Microsoft is always popping up boxes to waste your time and irritate you. All right. Okay. And so I want to find Virtual Protect. Okay. Which is JavaScript, Python. See if I can move by page. There we are. Ruby. Register setup for Virtual Alloc. Ruby. ROP chain. Okay, let me read my instructions so I don't have to hunt too long through here. Find the register setup. Then down, I thought, well, I do want the Python code. Okay, good. So this is register setup, okay. This is Ruby. And this is C. And this is Python. There we go. Okay. So I want the Python code. There. There. I'm going to copy that. Okay. Now I'm going to go back to my machine here, and let me get my instructions. Okay. After you've got it, nano ROP chain and put it in. Okay. Nano ROP chain. And put it in. Okay, there's the code. Now, there's a few things we have to fix about this code. The first thing is, of course, indentation matters in Python. So you have to get rid of these leading spaces. But you can leave it heavily indented there, and that's harmless. You have to get the first and the last line to stop being indented. And also, this is actually Python 2 instead of Python 3. And I had trouble finding a solution, but I think the solution is just this, B. Because Python 3 has byte strings, byte arrays, which are different than strings. And they were the same in Python 2. Now that's a byte array. I think that's all. Let me check my instructions. Fix the indentation and add a B. Yeah, okay. Now that'll do it. Now I just need to add some code at the top. Let me get it. So I'm going to save what I got here. Now I'm going to copy one of the ones that worked, like testnx, cat test nx. This stuff at the start is the same. I don't know if that part's the same, but I'm going to take it. Let's see what I wanted. I wanted the prefix. Oh, I'll just copy. I see. Okay. I want to get the right address. So I'm going to copy this part from here. Okay. And now go back in here and put that there. Okay. Now I'm going to get this part from here. Okay. And put that in. There. Now I've got my jump ESP. Okay. Now I'm going to add code at the bottom. It does this. Okay, so now I take the prefix and I add the ROP chain here. Then I put the attacks down here, NOP, sled, break, and padding after the ROP chain. The ROP chain is going to turn off this defense. And then it will execute the code that comes below there. That's the idea. So that's the game. I should now have my fake exploit that will run even on a non-executable stack. That's the idea.
And after you run that code, the NX remains off.
Yeah.
remains off.
Yeah, it's gonna turn off that feature for this memory, block of memory.
But only, that's what I'm saying, only for this operation or?
Only for this process and that one block of memory, right, exactly. So I run that, and now I should get the same thing I got before, I should get the int command. So let's get rid of this notepad file and go back to the CPU memory and do debug restart. And then run it again, and now send the ROP chain attack. Okay, and it didn't like struct, so let's see what happened. Oh, oh yeah, I made a mistake. When I copied stuff, I failed to fix the imports. I had to import not only socket, but also struct and sys. So let me fix that. I was a thing I needed to import. Here, there. I just need to bring in a few more libraries to do this, struct and sys.
And you added a K?
Oh, no, I don't want the K, thanks. Good, good. The K is how do you kill a line, but I didn't hit it correctly. Good, so now I should be able to run that. Okay, and now if I look here, thread terminated, still running. Well, that's not good. All right. I might be in trouble. Let's look at ROP chain and see if something's wrong like the address. No, that looks right. There's the break. There's the ROP chain. Attack is this plus ROP chain. It looks pretty good, but it didn't seem to cause anything to crash. Thread terminated, exit code, that's disturbing. Let me try debug restart. Yes, oh, let me see if I can get the comments on Twitch over here. Uh-oh, a lot of old comments. Good, okay, good. I hope the Twitch feed came back. It looks like it came back here. Anyway, debug restart. Yes. And run. Okay. Now, run the ROP chain. And it just says thread terminated, exit code 0, which is pretty disturbing. What did I do wrong here? It should have hit the int3, and it didn't. I wonder if there's something else I had to have up here. Oh, yes. I think that's the bottom. I think, nope, nothing happened up here. All right, I'm going to compare my code to my example there and see if I can see what I've done wrong. Nano, okay, nano. Man, minus y none to get rid of the stupid worthless colors. ROP chain. Okay, user bin python 3. Import socket struct sys, put in the address and the port, prefix, EIP, nopsled and break. Okay, then you create the ROP chain, and that should have 77. Ooh, completely different stuff here. Ah, I got the wrong gadgets. I got gadgets.
Even the server is different because you have a.
Well, I think I might have copied the wrong stuff. No, gadgets to set ESI. No, maybe that's all right. Pop EAX return. Pointer to virtual alloc. No, it looks like it's okay. It's different, but I guess it's just different on my system. This looks like the right stuff. Let's see if the code at the bottom looks right. F is 3000. That's got the thing plus ROP chain, then nopsled break padding. Well, I'm wondering if it has something to do with the versions of Windows 11 or something horrible like that. Well, I may just be hosed again. I tried to do this a few weeks ago and it didn't work. Looks like, again, it's not working. That should have done it. I should have hit int3. If an access violation happens, then you have to remove null characters. This might be a problem. Yes, sometimes the ROP chain has null characters. Let me try this. This might be the flaw. This was what happened to me before, and I think it's just random. So you have to add a line here. Okay, ROP chain equals ROP chain. I think that might be it. Let's try that. Replace null characters with nothing. All right, let's see if that does it. All right, let's get my thing working again. Debug, restart. Yes. And run. And byte-like object is required. Okay, it must be a B. There, replace it with, see if that works. Thread terminated, exit code 0, running. It seemed to work fine. Let's see what this says. Waiting for client connection. No, it's not an overflow anymore. That does seem very much like a null byte problem, where it's terminating the string before it gets in. And that's probably one of my ROP chain addresses probably contained a 0. I might even be able to spot it. Yep. No, wait, no, that looks like a 0, but it's not. Well, it's not even hitting the buffer overflow anymore. I wonder if I have to run the ROP generator again, and maybe it'll give me a different answer. There might be some randomness involved. I think this exploit somehow has a bad character, which means I'm not even hitting the buffer overflow anymore. I'm not even crashing the server anymore. And that is kind of to be expected. So that may be a problem. I didn't know that could happen. It didn't happen last time. But anyway, then I just had to generate shellcode. And I used MSF Venom to create real shellcode and add it in, instead of my fake one, which I think we've done before in the previous one. And so then you put in real shellcode and you'll be able to connect. So I got very close to the end. And I think the answer is to just repeat the generation of the ROP chain. But that's what I wanted to show you. You should be able to make some progress on this. And I'll see if I can figure out what went wrong there. Anyway, I'm going to stop this video.